should make us a lot happier. The problem wasn't that these factors don't matter. The problem was that we're using the wrong methodologies. And we should always go by and check these things. So here's beach, here's charter. Again, look at the own price effect, it's negative and significant. The cross price effects are positive and significant. The catch rate for charter is positive and significant. The cross catch rate effects, if you want to call them that, are negative and significant. Income is negative and significant. And yeah, same thing with peer. Everything's the right sign, everything's significant. And then finally with private, everything is the right sign and everything's significant. So this is the right model. These are pretty solid results. We're pretty confident in these. Our problem is we were just using the wrong methodology. Let's see. Stat MFX GUR list. This is just the yeah, we don't have margins plots, so we can't do all that kind of good stuff. We don't want to do that. If we were to test the independence of irrelevant alternatives, we can do it by hand. Remember the MLOGIT test or MLOG test only works for multinomial logit. This isn't multinomial logit, this is alternative specific conditional logit. We can do it by hand. Essentially, we can estimate a full model, and this is all of our variables and all of our categories. We store this, and I'm going to store it under the name unrestricted. That's the model we've already run. Then we're going to take, we're going to run a series of these restricted models, and by restricted, we're going to just eliminate one of the categories, and then we're going to compare those coefficients and the variances of those coefficients. And again, we don't have to do that, Stata's going to do it, but all we have to do is run the regression. So notice that I'm saying run it for everything else except for fish mode not equal to beach. So get rid of that. Simple enough. And then there's a command for our Houseman test. And again, there's that same difference in the regression coefficients, difference in the variance of the coefficients. We get a negative chi-squared statistic, which is indicative of a retaining the independence of irrelevant alternatives. So we haven't violated it according to our Houseman-McFadden test, who themselves say this test doesn't really work very well. Don't trust it. We can do that for each of the categories. Remember the MLOG test command does it for all the categories in one shot. Here we're doing it by hand. We do, this time we're going to eliminate charter. Run the same test. And again, we get a negative Houseman-McFadden statistic, which again indicates that we have not violated the independence of irrelevant alternatives. All right, this, do that. Yeah. We could try to get around the independence of irrelevant alternatives by using our multinomial probit, but as we said in the PowerPoint, these are computationally intensive and they don't converge half the time. So, but what we're able to do is allow for, in this case, allow for the structure of our error terms. Here unstructured, heteroscedastic. So let's see if we can't do that with our other data set. This doesn't work here. So this data set is So let's go to the saltines data set. Crackers. The reason I like the fish data set, the fishing data set, is because it has both alternative and case-specific variables, even though it doesn't work in some of the methodologies. But in all honesty, you're probably going to have both those types of variables. So, all right, so let's run our multinomial logit. This is what we've already done. Again, we know it's wrong, but we just can't help ourselves. How many times have you said that? All right, we got all these results. Relative log of the odds ratio, all that good stuff. We need to convert this data, and this is how the data comes from Nielsen and RI. It's going to come in this long form where we got prices and promotional aspects. For each of these, we need to convert this from long form to wide form. So we're going to cut off these nubs. We're going to cut off price, and we're going to just price for all of these. We're going to cut off display. We're going to cut off feature, and we're going to cut off feature and display. So we need to reshape the data. I think we have observations in here. I think I've already done that. So we go from 3,200 to 13,000 observations. We constructed this new variable called brand. That new variable is going to be a string variable, and we have to indicate that because I think the default is a numeric. So indicate that it's a string variable. It won't run if you don't put the string in there, by the way. And it tells us exactly what we did, what they did. We cut out price, Keebler, price, Nabisco, and constructed a variable called price. We cut off display, Keebler, blah, 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 and created a variable called display. Feature, just created a variable called feature. And then feature and display, we created a variable called feature and display. So again, we've multiplied all these times. We have 4 crackers? Yeah. So 4 brands. So this is going to be 3292 times 4 is going to give us that 13,000. Let's see. Remember that we constructed choice, and it's literally a multinomial, 1 through 4. That's not what our McFadden choice model or our conditional logit model wants. Our conditional logit and McFadden choice model wants a binary, 0, 1. And it wants the data set up so that it indicates which of these which of these purchases that we made. So to do that, we need to drop choice. And here comes the hard part. We need to run this little program. And basically we're going to regenerate choice. And essentially what it does is that for each brand name, Keebler, Nabisco, Private, and Sunshine, so generate choice equals 0, and then for each brand name, Keebler, Nabisco, Private, and Sunshine, replace choice equals 1 if 2 things hold. 1, the brand, because remember there is brand here, and then there's something called brand name that we generated for the for each part. We want to replace the 0 with a 1 if the brand equals the brand name. In other words, if the brand you chose is indicated by the brand name variable. And that's basically what that's saying. So those 2 things have to hold. Those 2 things have to be the same. Now, if we do that, we should be able to tab choice.
It's a little thing in your default.
little squiggly thing, or this thing?
That's making
It's the group.
It's going to construct that as soon as you create that, as soon as you type that open bracket, I'm sorry, that bracket pointing that way, it's gonna, tells you that's the loop part of the program. What'd you call it?
It's usually we call it group.
Group, yeah. The group's the program. So, you'll see it as soon as it pops up. I'm sorry, as soon as you type that thing, it'll pop up. So we tab choice, it's a binary. You should always do tab missing because these models are sensitive to missing observations. So we want to make sure you don't have any, and we don't have any missing observations, so that's good. All right, let's check out our data. Let's tab gen our brands again. I think we need these. So, there's the brands that we just, I'm sorry, those are the brands that were generated in the reshape. This column. These were generated in the reshape. Those brands were generated by us in our tab gen command. And again, I changed the case because we can't have them exactly the same, otherwise they don't let us do that. And we can see which choice was made. So the choice is a binary, it's going to be 0, 1, and we can see that the first person chose Nabisco because their choice variable is 1. The second person chose Nabisco, and the third person chose Sunshine. So the data is set up now correctly for, and so there's different ways we can do that. So we can do this conditional logit model. And this is essentially going to replicate our multinomial logit model. I'm sorry, our alternative specific conditional logit model. It'll come close. Where is, it's our conditional logit model. What's that?
There's 4 brands.
Yeah,
Only using 3.
we have to exclude one of the demos.
Okay.
Yeah. Margins doesn't work, and neither does MFX with conditional logit. It does work with our McFadden's choice model. Again, another reason to like. Now, and this gives us our, that's all we got, these alternative specific variables. We don't have any case specific variables. This gives us our alternative specific variables. Again, price, negative and significant. Feature, positive and significant. Display, positive, not really significant at conventional significance levels. And feature and display. Again, the nice thing about this is, let's assume that we constructed those nice graphs from our multinomial logit model, which again we know is technically not the right model. We can still look at our results from our alternative specific conditional logit model using, bless you, using our MFX command. So again, this should answer the email I got last night, was it last night or the day before, about results not really coming out significant. So, start with price. Log demand holds, it's negative and significant. Cross price effects are all positive and significant. That's good, everything is fitting well. Feature, positive and significant. Cross promotional effects, negative and significant. Even display has the right signs. It's positive for the own display, negative for the cross displays, but they're not really significant. And then feature and display are again positive for own effects negative for cross effects, and we can see this pattern holding for not just Keebler, but for Nabisco. And again, display is statistically insignificant. We can see it holding for private, again, negative price, own price, positive cross price, negative or positive own feature, negative cross features, right signs for display but not significant, right signs for feature and display, and everything significant. And then finally for Sunshine, we've got negative own price, positive cross prices, and again, the only thing that's not significant, although still the right sign, is going to be display. Remember when we did the multinomial logit, not everything was significant. We just got a lot of weird results. And that's why, because we were using the wrong methodology. Good pictures, but not great results. That was the problem. We don't have margins. We don't have margins plots. That's the Hausman-McFadden test again. Let's do a nested logit. All right, so first thing we do, so nested logit, like conditional logit, like alternative specific conditional logit, the McFadden choice test, has to be in long form as opposed to wide form. Data is already in long form, which is good. First thing we've got to do is define our tree. So we're going to generate this variable called type. I'm sorry, we're going to generate this variable called brand, and we're going to distinguish between two types essentially. So this is our command here. We generate this variable called brand. We can call it anything we want. We're going to call it brand, and we're going to distinguish between two types of crackers. One generic, and the other branded. So let's assume that that's how we're going to categorize things. So we have to assume that most people don't view generic and branded crackers as substitutes. They're either going to buy branded crackers or they're going to buy generic crackers, but they don't view them as substitutes. Again, that's an assumption we have to make. But if you choose to buy a branded cracker, then you have these substitutes of Keebler, Nabisco, and Sunshine. So that's our kind of working assumption for using this nested logit model. So we do that, and it literally just shows you, okay, I constructed these two things. All right, A for me. This just shows us our tree. So generic is called degenerative in that there's only one choice. If you pick generic, you're picking private. And then branded has the three choices. And now we can run it. Here's our command. Again, normally you can have both case and alternative specific variables. We don't have that in this data set, unfortunately. But let's see. Yeah. So here's our choice variable. Here are our alternative specific variables. And our generic and our brand. And it's a maximum likelihood methodology, so it goes through the iterations. It regenerates our tree. And we get this result. Price is negative and significant. Feature is positive and significant. Display is positive but not significant. Feature and display is positive and significant, so we're getting again consistent results. These fixed effects or dummies that are included in the regression just indicate that, for example, Nabisco is 1, so we're more likely to pick, if it's positive, we're more likely to pick Nabisco relative to the base category, which is Keebler. This is negative, so we're less likely to pick private relative to the base category, Keebler. And that's true of Sunshine also. We're less likely to pick Sunshine relative to the base category, which is Keebler. Our dissimilarity index, remember that's kind of an indication of how well we separated out our categories or nests. The null hypothesis here is that our dissimilarity index is equal to 1 for both of these categories. We get a large chi-square, a small p, so we can reject the null hypothesis, which means that these are distinct categories. So if those two dissimilarity indices are equal to 1, then we're not violating the independence of irrelevant alternatives. Okay. Because they're not substitutes. This is nice because we can construct that tree diagram. We would have boom, I want some crackers, and we got generic, branded, marginal effects and MFX doesn't work. Changing the base, yeah, we can do that. All right, so let's do some post-regression stuff. So predict P level star, and there's only 2 levels, and then you got the PR option stands for probability. So this is just going to generate probability levels for each probabilities for each level. And we can tab these. And these are really nothing more than the relative frequencies. But what we can do is start doing this. So 31% shows generic, and 68%, 69% chose branded. Those are our top level probabilities. The distribution of our top level probabilities. This is kind of cool. If you're into these kinds of things. So this is the same graph overlaying, and you can see that the distribution of probabilities for each type, generic and branded, are pretty normally distributed, even though they're shifted over. So this one is centered on 0.31, and this one's centered on 0.69. So all right. Tab, these are the the level 2 probabilities. Now these, if you recall, and you should have them, are nothing more than the relative frequencies. I think I just had you do the frequencies. But for the relative frequencies, we knew Nabisco had 54%, and then private at 31%, and Keebler and Sunshine had pretty similar, about 7%. So these aren't that useful. What we want are the conditional probabilities. We want to say, all right, given that you've chosen to buy a branded cracker, what's the probability now that you choose among the 3 brands? And those are our conditional probabilities. And these are here. So what do? To get the conditional probabilities, I'm going to column conditional probability, conditional P, and then my option is conditional probability, and then hierarchy level 2. And that gives us these conditional probabilities. And these tell us that, remember that generic is degenerative, there's only one choice. So once you've chose generic, there's 100% probability that you're going to buy generic. But once you've chosen branded, there's a, now we can break this down into 1, 2, 3. We've got Keebler, Nabisco, and Sunshine. And now we know that choosing Keebler, you get about a 10% probability. Choosing Nabisco, you get about an 80% probability. And choosing Sunshine, you're going to get about an 11% probability. That's pretty cool. Yeah. On top of that, again, I'm a huge fan of this. On top of that, we should be able to measure marketing effectiveness, promotional impact. So if we do that, or to do that, and again, these probabilities, this is just to show that these probabilities should sum to 1. So 8, they sum to 1 there. But I guess I'm rounding error. We're off by 0.1. Is that right?
So 79.
Yeah. Is it 79?
Yeah, 78.9.
Oh, 79. Yeah. I rounded too much. Must have flunked that class. All right, so those should sum to 1, just as they do for the degenerative private one. And again, that's good. The model's consistent. It's always good when things are consistent. Let's see. All right, measuring the effective promotion. So we can do something along the lines of this. So all I'm doing is making a table. Now, this doesn't make any sense because types don't promote, brands promote. So I don't want 2 things. I don't want to categorize things by type, and I don't want to analyze level 1 probabilities. These are level 2 probabilities, so I want to analyze those. So I just showed you that to throw you off. That's what I do. Okay, so what I want to do is this. Just a tab. Brand, and you're going to have to do this for each of these categories of promotion, and these are the conditional probabilities. So we know that these are on average going to be, let's see, this is Keebler. Yeah, those are the relative frequencies. Where's Keebler? Is that right? 6 and 7. Oh, yeah. We're not done yet. All right, so for Keebler, we can break this down into display. feature, feature and display. So when it's not promoted, essentially what we have is 0.0, let's call that 0.07. So essentially what I would do, let's do this first. Let's just go to promotion. So when display equals 1, our probability of purchasing is 0.08. And one of the reasons I like this tab is that you get a little bit more information, right? You got sample size here of both the yes and the no's, both here the yes and the no's, and you've got, it looks like you've got the standard error. But if you wanted a more compact version, we could have just done table. Table's going to give us a more compact version that we could, for example, pull out of here and put into Excel. Get the same results. So Keebler, are they the same results? No, these are different. Something's wrong there.
Well, wouldn't 0 be the number, the percentage on
Yeah.
non-promoted and 1 be promoted? You have to break down 1.
Yeah, but these are coming out differently. So standard deviation is where it is. Mean standard deviation, yeah. So I want the table ones. Yeah, so this is going to be 10% versus 12%. .12 there. And then I would do the same table for feature. Conditional probability is going to be 0.22%. 0.22, oops. And for feature and display, it's going to be 0.31. That's pretty cool. So, you can treat this top level as the non-promoted probability of purchasing. Can we increase that probability? Sure. Display increases it marginally. And from the regression results, we know that it was display that was insignificant. But feature was significant. It increases the probability of, it doubles the probability of purchasing. It goes from 10 to 22%. And feature and display triples the probability of purchasing. It goes from 10 to 31%. So